Code Explained says hi. So this is the second part of our tutorial of how to create the tic-tac-toe game using JavaScript. In the first part, we created a game where you can play with just a friend. So you choose the opponent, your friend in this case, then choose your symbol and hit play. And then you can play with your friend. Now in this part, the second part, we are going to implement a simple AI yet unbeatable into our game. So I'm gonna try that. I'm gonna go and play versus the computer. I'm gonna go for O and then play. Now I will go for the space in the center. You can see that the computer chose the space here. I'm gonna try to beat the computer. So now he's preventing me from winning. Same thing here and the same thing there, and now it's a tie. So let's code this, but first, again in this tutorial we're going to see the logic behind all of the code, and at the end we're going to type in the code. So let's go. Right, let's start our tutorial from this point. Let's say it's now the computer's turn and he needs to figure out which is the best empty space for him to play. The computer is playing with X's and the man is playing with O's. The first thing the computer will do is to look for the empty spaces because it doesn't have eyes. Now the IDs of the empty spaces are 1 and 4 and 8. So in terms of code, he will create an array called empty spaces which has all the IDs of all the empty spaces. Now the computer needs to go for the best move that will make him win or at least get a tie game. It's simple. The computer will go and play all of the empty spaces one by one and see the outcome of each move. Then he will decide which one is the best. So he will go and play 1, the first empty spaces, which has the ID 1. Now he can't yet decide if it's a good or a bad move. He still needs to play for the opponent, the man in this case. Before doing that, he needs to look again for the empty spaces because again he doesn't have eyes. The empty spaces IDs are 4 and 8, which means the man can go for one of them and the computer needs to check the outcome of the man playing them both. Now you can see that the man is winning the game no matter what move he makes. So no need for the computer to play the left empty spaces. Now after the computer knows the outcome of playing first the empty space with ID 1, now it's time to clear the board and play the next move to see what will be the outcome again. Now if he goes for 4, he wins the game, so no need to play for the man in this case. Again he will clear the board and go for the space which is the one with the ID 8. Again the man could play 1 or 4. If the man goes for 1, the computer can still get a win by playing the space with the ID 4. But in case the man went for 4 instead, he wins the game and no need for the computer to play furthermore. Now that the computer knows the outcome of each decision, he can now decide what is the best empty space to go for. But how can the computer knows he doesn't have eyes? So each time the computer make move, he will need to see if he is winning or losing the game. For example, here the computer is winning, so he will evaluate this move as +10. For the other move, he is losing the game, so he will evaluate that move as -10. So the idea here is the computer will give a static evaluation, I mean a positive number when he wins and a negative number when he loses the game. So if the computer wins, it's a +10, and if he loses, it's a -10, and if it's a tie, it's 0. So positive numbers will favor the computer and the negative numbers will favor the man, and 0 will favor none. So we are seeing here that the computer is maximizing the evaluation and the man is minimizing the evaluation. That's why we call this the minimax algorithm, because we have a maximizer and the minimizer. Let's see how this algorithm works with an example. Let's say we have a game with two players, green and red, and when one of them make a move, the other one will have two open positions to play. So for the green player to evaluate this position here, whether it's a good or bad move to go for, he needs to go deeper in the game. How much deep, it depends. So he will go and play for the red player. Again, to evaluate these position here, he still needs to go deeper. And so on until he decides to stop or the game simply ends. Now let's say these positions here come as +1 and -3. The green here is the maximizer, so he will go for the highest evaluation, of course. So he will go for the position that leads to a +1. So the evaluation of this position here is +1. In the other side, let's say these comes with a -1 and a -3. Again, the green player will go for -1. Now the red player is the minimizer, so he will go for the lowest evaluation, which is -1. Now in this case, the man would go again for +5, and here he will go for 4. Now the evaluation of this position here for the red, which is the minimizer, is +4, and now the evaluation of this position here is +4. So the green will go for +4, then the red will go for +4, and the green will go for 4, and he will win the game. But instead of the green chose to go for -1, the red will go for -1, and the green here will lose the game anyway. So that's the same thing we're going to do with our game. So the computer here is the maximizer and the man is the minimizer. So the man here in this position here would go for -10, and in both the cases he wins the game. Now in this case the man is the maximizer, he only have this choice, so it's a +10 as evaluation for this position here. Again, the man is the minimizer, he won't go for 1, he will go for 4, then the evaluation of this position here is -10. Again, the computer here is the maximizer, so he will go for the position that have a highest evaluation, which is 4. And he will win the game. Now, let's see how this works using JavaScript code. So the first thing we need to create is a function called minimax. Now, if you remember, the first thing the computer needs to know is what are the empty spaces. So the first parameter is the game data array. And also sometimes he will play for himself and next time he will play for the man. So the second parameter is the player. Now when the first time the minimax function has been called, it's the computer's turn. So the player here is X. Inside the function, the computer will need to look for the empty spaces inside our game data array. Remember, game data is a one-dimensional array that has all the filled and empty spaces in it. Then the computer will try and play the empty spaces one by one, so we need a for loop. Then the computer will evaluate every position or every move. Now inside the for loop, the first empty space ID is 1. He will go and play that space for himself and create an object called move to save the ID of that move and its evaluation. Now, to get the evaluation of that move, the computer needs to go deeper in the game. Again, he needs to look for the empty spaces, the left empty spaces. Again, use a for loop to see the outcome of all those empty spaces. He will go and play the space with the ID 4, but remember, it's now the turn for the man. Again, save the move's ID and its evaluation. Now to get its evaluation, he needs to go deeper again in the game. But wait, don't you see that we are just typing the same code? And yes, we are. It's just our function minimax. But this time it's called by the other opponent, the man. That's where the recursion happens. It happens when the function itself is the callback. So when the function is calling itself by itself. Now to evaluate this move, we need to go deeper. We call the minimax again, but it's now the computer's turn. But wait, a big wait. The final code, it's not gonna look like this, right? This is just a way of simplifying things. We are not going to write all this code again inside the function minimax. It has no sense, because the code here is already there. I am creating this rectangle here, so for you to know that we are just calling the function, and this is what will happen inside. So in the final code, it's just whenever I need to evaluate the move, I will use an if statement. So for example, on the final code, when I want to evaluate this move here, all I'm gonna use here is just calling function using an if statement. So I'm gonna say if the player was X, then call the minimax function with O. Else, if it was O, then call the minimax function with the other player, which is X. So I am doing this just to know what is happening in the background. Okay, now when we call the minimax here, we are in this level here. So you have to say stop. The man is already winning. And yes, so before we go and check for the empty spaces again and play a move, we first need to check if there was a winner or a tie. So here, before I check for the empty spaces, I will use an if statement. So if wins return an evaluation of -10. If it's X, the computer, the maximizer, if X wins, return an evaluation of +10. If it's a tie, then return an evaluation of 0. We call this a base because that's where the recursion stops happening. So the minimax will keep calling itself until it gets to the base, until there is a winner or a tie. Now here, our wins will return an evaluation of -10. So now simply to get the evaluation of a move, we simply need to say minimax.evaluation, because here in the base here we are returning an object with the property evaluation. So to get that property evaluation, we're gonna call the function doing.evaluation. Now this function here will return back the evaluation -10 back to this function here minimax. So here the move that evaluation of the move with the ID 4 will be -10. So that's it. Now we need to go to the next one, to the 8 here. But before that, we need to clear the space here because the space is already taken here. So we need to get back our space. Now we are going to do the same thing, play for the man, save the ID, save the evaluation, and then to get the evaluation, we need to call the minimax function again with the other opponent. Again here, O wins, so we are returning an evaluation of -10. So here, the move that evaluation equals the minimax game data x that evaluation. Here, the function again will return the evaluation of -10. So the evaluation of the move with the ID 8 is minus 10. Again, we need to clear the space or restore our space. And now it's time to evaluate the move with the ID 1 here. So I'm just gonna say minimax.evaluation. The problem here is we don't get to the base, so we can't get the evaluation as we did here in these examples. But if you remember, to evaluate this move here, we use the minimax algorithm. So to do that, in this case, we need first to save these moves. And to save them, we need to create an array called moves. Now, after I evaluate this move here, I'm gonna push that to our array moves. And I'm gonna do the same thing here. Now our moves here has all the moves with their IDs and evaluations. Now we will use the minimax algorithm to choose one of them. So if the player here is the computer, we are going to choose the max in moves, means the one with the highest evaluation, because the computer is the maximizer. Else if the player is the man, we choose the minimax, means the lowest evaluation, because the man is the minimizer, and then return the best move object. Now when we return the best move object, to get to the evaluation property, I'm just gonna say minimax.evaluation, and then minus 10 will be the evaluation of the move with the ID 1. Now you can feel a bit dizzy, and I hope you're not, but if you do, let's rearrange this code. So we're going to create the function minimax. The parameters are the game data array and the player. The first thing inside our minimax is the base. So is where we say if the winner is the player that man, return the evaluation minus 10. Then if the player is the computer, then the evaluation will be plus 10. And if it's a tie, then the evaluation will be 0. Then the next thing is looking for empty spaces inside our game data array using a function called empty spaces. We're going to talk about this function in a minute. And then use a for loop to loop over all the empty spaces. Then I'll need to get the IDs. Then I will need to save the ID and the evaluation inside a variable called move. So I'm going to save the ID, and then I will also save here. It's like I'm doing a backup of the space because I'm gonna fill this space, and remember the game data here is the original array. So we are working with the original array, so we don't want to mess with it. So I'm gonna save each time that space, and then after I finish, I will restore that space back. Now after the backup, I will go and play that space for the player, and then to evaluate that move I will use an if statement. So this is where the recursion happens. So I'm gonna say if the player is the computer, then call the minimax with the player that man. Else if the player was the man, then call the minimax with the computer. So when we call the first time the minimax with the computer, it will go and look for a winner. If there is not, it will look for the empty spaces, then loop over those empty spaces. When it gets to the if statement, now the player is the computer, then it will call the minimax function with the man. Again, we will go up, then check for the winner. If there is not, look for the empty spaces, then use a for loop. Now the player is the man, so now it will call the minimax function with the computer. Go back, check if there is a winner. If there is a winner, return the evaluation back to the function and return it back to the other function until we get here, and then we continue our code. Now we restore our space, and then we push the move into our array moves that we create outside the for loop. Now our array moves here will have all the moves with their IDs and evaluations inside. Now we need to choose one of them. So this is where we use the minimax algorithm. I will create a variable called best move here and then use an if statement. So if the player is the computer, then this is the maximizer, else if it's the man, this is the minimizer. Now I will need to look inside our moves array and look for the move that has the best evaluation. So here I'm going to create a variable called best evaluation and then I'm going to set it to a small number minus infinity. And then all the evaluations here inside the moves array, I'm going to compare them to the best evaluation here, which is minus infinity. So here I'm looking for the highest evaluation, so I will have to compare them to a small number. And here, instead, we are going to set the best evaluation to a big number, which is plus infinity, for example. To understand this, let's see how can we get the best move. So I'm going to use a for loop. I'm going to loop over all the moves inside the moves array, one by one. Then I'm going to use an if statement. So I'm going to say f moves, first with index 0, the evaluation is greater than the best evaluation. So if this one here, the first one, the first move inside the array, has an evaluation greater than the best evaluation, then I want that because I'm looking for the highest evaluation. I'm gonna save that as the new best evaluation first and then set the best move here to that move. Then I will go to the next one, for example. So I equals 1, moves with index 1, that evaluation. If it's less than the best evaluation, the one we defined earlier, not minus infinity, I don't want that. I'm gonna go to the next one. I equals 2. Moves, f moves with index 2, that evaluation is now greater than the best evaluation or the last best evaluation. Then I want to store that as the new best evaluation and I will set that as the best move. And I keep doing that until I finish all the moves inside the moves array. And now at the end of our function, I'm going to return the best move object, which has two properties, the ID and the evaluation. Now let's see how do we get the empty spaces from our game data array. Let's say we have this array here. We have this x and now x, x, or x. They are filled spaces and defined means they are empty. Now our function get empty spaces will take in as a parameter game data. Then I will use a for loop to loop over the game data array. Then I'm going to use an if statement inside. So for example here, if I use an if statement on this element here, it's filled, so it will return true. But this one, it's undefined, it will return false. So if I say f not game data with index ID, for example, if it's true, this will be false. Not true is false. But if it's false, then not false is true. So this is how I will know the empty spaces. So always here we will have not false, which is true. And then this code inside the if statement will get executed. Then I'm going to push those IDs into an array called empty spaces. And when I finish looking for the empty spaces, I will return the empty spaces array. Now if you remember, this is our board. These are the IDs of those spaces. But to draw on the board, we need to know the number of the column or the number of the row. So without them, we can't draw on the board, or we can't know where to draw on the board. So when it's the computer's turn, he will call the function minimax. But what it's really important, it's not the evaluation, it's the ID of that space that he will play. So he will save that ID to a variable called ID. But to draw on the board, he can't draw on the board using the ID. He needs to define its number of column and its number of row. But if you remember, we created an array, a two-dimensional array called board, and every ID here has its own row and its own column. So to get the ing of an ID, I'm going to use a function called getIj. So this will take in the ID and then use two for loops to loop over a two-dimensional array board, and then check if the board with index I and j is our ID, then return an object with the properties I and j. So this is how we will know the exact I and j, the column and the row of our ID here. So that's how the computer will know where to draw its symbol on the board. So now that I know the ID, it will say let space equals get ing of that ID. Then to get the I, the number of the row, it will say space.i, this one here, and space.j, this one here. Now let's open our text editors to type in the code, because I think you are ready to do that. But before that, don't forget to subscribe and hit the bell icon to get notified about every new video. So let's go. So the first thing you're going to do is to head to the GitHub or to the repo on GitHub. You'll find the link in the description. Then after, you will go to the repos and then find the Tic-tac-toe JavaScript. Now I will download all the files as a zip file, and now I will just copy the files for the second part. So I'm choosing here part 2. I will rename this to Tic-tac-toe, just the name of the game. Now I will open the text editor and open the folder of the project. I will go now live, so I'm running live preview of our project. Okay, I will open the console, and now I will go to the game.js file. So this is the code from the first part. Now I'll go inside the add the event listener. I will copy this code over from here because it's gonna be the same for the computer, just some little changes. I will use an if statement, so I'm gonna say if the opponent is the computer, then I will just indent this. Now here we will get the computer will get the ID of the space it will play using the minimax algorithm. So using the function minimax. The player, of course, is the computer. Now here I will need to play for the computer. Now we need to get the ing of the space. So let's space equals get ing. We'll see this function later. So this is going to be space.i and space.j. Here it will be player.computer, the same here. I'm going to say else. So if we are playing with a friend here, and now I will go and create the functions. The first one is the minimax function. This will take in the game data and the player as parameters. Then the get empty spaces function. This function here will take in as a parameter just the game data array. I will create an empty array, then use a for loop to loop over all the spaces inside our game data array, and then check if not game data means if it's an empty space, then push that space id to our empty array. I'm gonna change this to id. Now I will return the empty array, which has all the empty spaces. Now let's create our function get I and j. This will take in the id. I will use 2 for loops because I'm looping over a 2-dimensional array. This one for the columns. And then I will use an if statement to check if the board with I and j is our id, then return those I and j. Now for the minimax function, we need to create first the base. So if the computer here is the winner, then the evaluation is +10. Then if it's a tie, then the evaluation is 0. If it's a man, the evaluation is -10. Now we will get the empty spaces from the game data using our function get empty spaces, and then save all the moves in an array called moves. Then I will loop over all the empty spaces to evaluate them. So it starts from 0 and stops when it gets to the empty spaces length. Now I will need to get the ID from the empty spaces array, and then I will need to backup the space so I can restore it later. Then I will need to make the move for the player, and after I will save the move ID and its evaluation. So the move is an object, the ID is the ID, and to evaluate that move, I will use an if statement, so to check if the player is the computer, then call the function minimax to go deeper in the game, but this time with the player, that man. So this is where the recursion happens. After, I will restore the space and then push the move to our moves array. Now outside, I will here type in the code for the minimax algorithm. So I'm going to define the best move variable. Then if the player is the computer, the maximizer here, let best evaluation equal to a small number minus infinity, and then use a for loop to loop over all the moves inside the array moves, and then check if the moves with index I, that evaluation is greater than the best evaluation. Then we need to set that as the new best evaluation, and of course that's the best move for now. The same code here for the man, the minimizer. Instead here it will be plus infinity and less than. And after that I will just return the best move, which is an object. Now if I save, I can see here an error in the line 135. Okay, so I did a mistake. I should have used a semicolon instead of equal. Now let's check our game. So if I play the center one, so he's preventing me from winning. the same thing, and he is the winner. So this is it, guys, for this tutorial. I hope you guys like it. If you do, just like the video and don't forget to subscribe, of course, and see you in the next one. Take care.